So since this course was on energy efficiency, I thought of uh, giving a talk on one area that I am quite interested in, and also it is now a very, you can say from the consumer perspective, it is a very popular area. So we'll start with discussing the basics of electric vehicles and what parameters are relevant for general consumers and users, and then we will proceed towards how, what are the research directions which are very interesting by the way. So we'll go through that. So So the outline of my topic is, first we will discuss with uh, energy consumption part. Okay. So basically we will discuss fuel economy, cost and time of charging, and comparison of energy efficiency of various electric vehicle models available in the market. The next step, we will go through various research which has been performed on estimating efficiency of electric vehicles, various test environments, and what data acquisition methods they have used, and how they perform real-time testing, not in only in laboratory, but also by driving the vehicles in real roads, collecting the data and analyzing it. Then we will go to what are the various research considerations for design of electric vehicles, and as we know, the most important part is the thermal management and cooling, which essentially improve the efficiency of the electric vehicles. Finally, we will have a look on what are the various research directions, especially what are the new charging methods that is available. As we know, the major concern regarding electric vehicles is the charging aspect, okay, so that it can be taken for long route driving. Then we'll see whether hydrogen fuel cells can help in improving the efficiency of pure electric vehicles. And the last, which is the most important one, that is what are the various financial and social drivers that are going to help or that actually decide how much EV penetration might take place. For example, we'll discuss regarding this during our around the last of the presentation, that in spite of the subsidy that the government of Odisha is providing for electric vehicles, which is around 1.5 lakh for the EV cars, still the target of EV penetration has not been achieved. And the road tax, free road tax and all those things, but still people are somehow unwilling to accept EVs, mostly because of the charging infrastructure. Okay. So we'll start with part A. Here we will discuss the basics of energy consumption, which many of us are quite aware, but still it is better to review what actually matters before going to the research. So how do we compute the fuel economy? So whenever, especially in Indian markets, every vehicles is generally compared in terms of the fuel economy. So one such unit is MPGE, okay, gasoline equivalent unit. So miles per gallon gasoline equivalent given by the Environmental Protection Agency of the United States, but this unit is may not be relevant for general public in our country. So real world EV efficiency can also be expressed in miles per kilowatt hour, which converts EPA values to direct energy consumption. Now this miles per kilowatt hour, again we are more familiar with the kilometer part. So for us it will be kilometer per kilowatt hour, we can say. How much kilometer in per unit consumption, how much kilometer the vehicle will move. And if a further unit, a better unit will be per 100 kilometer, how much kilowatt hour is going to be consumed for the electric vehicles. So we consider some popular electric vehicles. I think Nexon and XUV are the most popular now so far. So they have a battery capacity of around 40 kilowatt hour or 40 units. So from popular data collection, we can say that the range of the vehicle is around 250 to 300 kilometers. So each full charge, the vehicle can go up to 250 to 300 kilometers. So how can we compute the efficiency? So 100% means 40 units, okay, and for 40 units or 40 kilowatt hour, it goes around 250 kilometer, then it will be around 16 units per 100 kilometer. Also, if we consider the 300 torque, it is around 13 units. It's very efficient. It's 13 units per 100 kilometer. So that note these two values, that one is 16 units per 100 kilometer, the other one is 13.3 units per 100 kilometer. Okay. Now, if you consider the cost, what will be the cost? So average cost for power in our state is around 5 rupees per unit. So it will be around 80 rupees only for 100 kilometer, whereas in this case it will be around a mere 65 rupees per 100 kilometers. So these are quite efficient or cost effective, these electric vehicles, the popular ones. Now we will formally calculate this cost. Okay, we will consider again the EV with a capacity of 40 kilowatt hour or 40 units. Again, considering rupees 5 per unit, cost to fully charge will be about 200, right? This will be about 40 into 5, 200. If the vehicle goes a distance of 200 kilometers with a full charge, I am taking a very conservative amount. Okay, okay, I have taken 250, so I will consider 250. So it is around only 80 paisa per kilometer. Is only 80 paisa per kilometer. So if you consider a diesel vehicle, then assuming diesel or petrol vehicle, assuming 15 kilometer per liter fuel efficiency and rupees 100 per liter fuel cost, it comes around rupees 6.67 or rupees 7. So EV is 7 times more cost effective. I won't say fuel efficient. So it will be, the better word will be cost effective. Now, but this cost effectiveness comes only when we charge the EV at our homes, where the domestic tariff is very low. But if you consider any charging station which comes on the road, many companies are providing charging stations, static. We have in Orissa mostly Tata Power based charging stations. So here, if you see, the cost is very high. It is about rupees 19 per unit. That means about 4 times that we will spend by charging the EV at home. So it is always better to charge the EV to full charge before we leave our home, because the cost of charging stations, the unit cost is very high. So even though in that case also it is coming around 3 rupees per kilometer, which is at least 3 times better than, or 2.5 times better than the diesel or petrol vehicles. But if we go on a long route using our EV, then this advantage of electric vehicles with lower charging cost, that vanishes because of the high charging cost of the charging station. So one such one method which is mostly in the policy domain is to reduce the charging cost for the fast charging stations. Next, considering the charging time, this is again how fast we move around the, so we have a big country. Suppose we want to drive a longer distance using our EV. So how much time it will take? How much time we need to break to charge the EV? So consider again the battery capacity of 40 kilowatt hour, which is the battery capacity for most popular Nexon and XUV 400 EVs. Now at home with a 3.3 kilowatt charger, which these vehicles generally provide for free, so charging time for full is about 12 hours. And a general consumer don't go beyond 50% charge so as to charge it again. So every charging will take around 6 hours, every charging per week or within 3-4 days. With a fast charger that these companies are also providing with a 7 kilowatt, provided you have the load demand or contract load, then full charging takes only about 6 hours. Okay. Now the fast chargers that are available in our state on road are mostly either 30 kilowatt chargers or 60 kilowatt chargers. So if you have a 30 kilowatt charger, the full charging time comes around 1.3 hours, whereas For a 60 kilowatt charger, it's around 40 minutes. Now please note that all these fast chargers, the charging current reduces as the charging proceeds. So it is always advisable to charge to maybe 90% or 85%, not to full, because the last 10% it will take more time because of the design of the fast charger. Now we will see, now we know that, so what fuel efficiency we have found out? We have found out that for our popular vehicles, the fuel efficiency is around 16 kilowatt hour per 100 kilometer, or 16 units per 100 kilometer, or 13.3 units per 100 kilometer. Now we will compare that, we will compare the EVs or electric vehicles that we are using with those available in the world, throughout the world, and across several years which have been available. It has been available for long. So these data I have got from the internet, from Wikipedia. So as we discussed, so say we will assume 16 kilowatt hour per 100 kilometer, 13 kilowatt hour per 100 kilometer, 16 to 13 kilowatt hour, 13 to 16 kilowatt hour per 100 kilometer is the fuel efficiency for the electric vehicles that are available on road in India. Now comparing the various models, Toyota Plus, so here only MPG is given, it's not an electric vehicle. So this is Hyundai Ioniq. Okay, so for this, if you see, it is around 15 kilowatt hour per 100 kilometers. So it is in between what we get on road in our country with the popular models. In city, it is still less, 13.7, whereas on highway it is 16.5 kilowatt hour per 100 kilometers. Another company, Lucid Air, 2023 model, again 15 kilowatt hour per 100 kilometer, combined city and highway. And I think these do not combine the regenerative braking capacity, which further improves the fuel efficiency. Tesla 2023 is higher than what we have seen here, 13 to 16. It's further higher. Higher is bad actually. So we are consuming more energy per 100 kilometer. Okay, in city they consume 16.2 per 100 kilometer, whereas on highways it is 18.1 kilowatt hour per 100 kilometer, maybe due to higher speed. Okay, more energy is consumed. Then another Tesla model 14.9, 15.9, and so on. So if you see here, another model in 2017, 17.2, 15.3, we continue seeing this. So for that, remember that in the ones that you are using here in India, the popular brands have about 13 to 16 kilowatt hour per kilometer. So which is much better. If you see here, if you compare with all these, the data available, and these are the practical ranges that I am talking about, not whatever they provide. They provide very high ranges, 300, 400 kilometer per full charge, but practically they give around 250 to 300 kilometer per full charge. But still, those are better than all this, you see. So everyone, you see, it is more than 16, even the most conservative one. Okay, and still there are some models like Mitsubishi, the earlier models, it is 21, which is very high. Okay, so if you need to know about all these details, you can go to the site, Wikipedia site, and you can find out all the energy efficiency. So our objective that we have seen so far is to find out how much units will be combined per 100 kilometer. Okay, and we continue, and you see the older models, 2012, 14, all these models is much higher, it's very high, 25.2 units per 100 kilometer, 28.3 units per 100 kilometer, 32.2 units per 100 kilometers. Okay, so that means the research has proceeded such that this value have been improved much. Okay, so from 25 and 28 or 32, we are now around 15 units per 100 kilometer on road that people are using. Okay, so research has tremendously progressed in the past decade with very improved, and hence that the whatever adoption of electric vehicles have been made is because of this only. Okay. Now I have followed this paper on Journal of Energy Storage. This paper is a very nice paper. It's a nice and comprehensive paper on electric vehicles. Review on energy efficient technologies for electric vehicles. It's a nice paper, you can go through it, and we will only discuss the salient points. So here energy used kilowatt hour per kilometer. Now we are assuming 15 kilowatt hour per 100 kilometer. That means for us it is around 0.15 kilowatt hour per kilometer. Now if you see here, so petrol, diesel, LPG, CNG, FCV, fuel cell and battery or electric vehicles. So here if you see the efficiency, which is in orange color, so this efficiency is about 1. Okay, it says efficiency is about energy use is about per kilometer. It might be the theoretical one, not on road, that's why it's supposed to be very high. Okay, I think energy used is this one, kilowatt hour per kilometer. Yes, so this one is the energy use, which I think around 0.3 it's saying, so that may be the theoretical one. So as you see here from this graph, compared to petrol, diesel, LPG, CNG, hybrid vehicles, fuel cell vehicles, the EVs, the electric pure battery electric vehicles have the lowest energy consumption in kilowatt hour per kilometer. So these are the most efficient, even much more efficient than the hybrid electric vehicles, the plug-in and hybrid electric vehicles. Okay, so this is with this we complete this part A, where we discussed about the basics of what we meant by energy efficiency of electric vehicles. Now we will go to part B, which will discuss the real-time test scenarios as published in literature. So I will start with a very small or a low scale testing, okay, not in a very popular journal, but this provides us an indication of in what direction this research has gone, so that we have now very efficient electric vehicles plying on roads. Now this research is from University of Jilina, where they simply used an electric car and practically measured the efficiency. The model is the motor rating. So with this we can have some idea about the motor ratings used in the electric cars. It's still higher, it's a small vehicles, 15 to 30 kilowatt motor, and the battery is about 300 ampere hours, 1.3 ton vehicle. Maximum speed is very less, 80. The currently available vehicles have a maximum speed of more than 120 kmph on Indian roads. Steel tube frame, length 3 meters, 31 meters I think, sorry 3.1 meter, small one, and wheelbase, all these things are given. Our vehicles, the vehicles, EV vehicles that are plying on Indian roads are much longer and wider. Okay. So in their testing, they have used 3 modes. They tested 3 modes. So for any electric vehicle, this is applicable. So any vehicle generally has one battery management system, which is for this battery pack management. Now the charger charges this battery pack, and you have a DC-DC converter, DC to AC converter. Depending on the motor, these converters can be used. So this is the motor that drives the vehicle, and there is a transmission. Now there is always one auxiliary battery for other purposes. Okay, and this is a typical charging mode. This is the mode of battery charging. Now while driving from the battery, the energy comes to the DC converter, and DC to AC converter. With this vehicle were using an AC motor, so there was a DC to AC converter. Okay, and for electric vehicles, one of the best modes is the regenerative driving mode, or this is a recuperation mode. So I think this is driving, this is recuperation mode or regenerative driving mode, recuperation mode. So in this case, as you see, when the mechanical energy from the wheel is converted back and charges the battery. Now this is provided in all the electric vehicles, and in fact practically this regenerative braking method helps in improving the range of the vehicle. The practical users have provided feedback that by using this regeneration, for example, you see a speed limit sign, or one sees maybe some traffic, and you simply leave your accelerator, then automatically the vehicle goes into regenerative or recuperation mode and the battery gets charged. For a longer distance, longer driving, this results in increasing the range by 20 to 30 kilometers. This has been the feedback from the users. Okay. Now, next, this is another such test in a test environment. This is not a real-time testing; it's on the test environment. So this journal is Applied Energy, published in 2018. Okay. So here it says, now what affects the efficiency of the electric vehicles or range of the electric vehicles. So one such effective ambient temperature. Now the surrounding temperature decides how much the vehicle heating will take place or cooling will happen, and accordingly the range will be changed. And the other one is using auxiliaries. Auxiliary means air conditioning. Now if as with petrol diesel vehicles, if the AC is switched on while driving an electric vehicle, then obviously the range will reduce. So here if you see this curve that they have provided, we can go through it. So you will see percent of all trips, here trip means the driving at different ambient temperature. So number of tests they have done. Okay, so this bar chart or histogram they have provided. Frequency of the trips with AC, no AC, AC equals to 0, AC greater than 0 means air conditioning is provided, and A equals to 0 means there is no air conditioning, whereas H greater than 0 means heating is provided inside the vehicle, and H equal to 0 means no heating. Okay. So we see here with AC greater than 0, the red one, okay, with as the ambient temperature increases, the samples that they have used, okay, so this data they have generally obtained from GPS, and this is the distribution of the trips at different ambient temperatures and number of such data. Okay, total data is this one. And these are the parameters as you see. So what is the purpose of this research? This research is actually showing how the ambient temperature and the use of auxiliaries like ACs, air conditioning, affect the electric vehicles. So energy efficiency in kilowatt hour per kilometer. So this unit we have been using from the very first slide. Okay. So here in this case is 0.14. So as we have seen, for our case it was 0.15 on practically on Indian roads. So we are This is exactly nearly similar to that. Air conditioning time per kilometer minute. So 1.14 minute. Heater usage during cold. Average travel speed kmph is 21 kilometer per hour. Travel distance is around 5 kilometers. Ambient temperature is 18 degree. Winter in India. Okay, and then various confidence intervals it has provided for various trips. Now, so what is the energy efficiency and how many samples are provided, what energy efficiency? So our reference point is always 0.15 kilowatt hour per kilometer for the roads plying on Indian, for the cars plying on Indian roads. So this is the actual energy efficiency, and they have estimated the energy efficiency by some models that they have provided. But as you see here, so most of the samples they have provided an energy efficiency of nearly to the same that we have seen. And finally, we'll see the efficiency at different temperatures. So this is the energy efficiency in kilowatt hour per kilometer, and this is the temperature. So as you see, as the temperature goes on increasing, the energy efficiency reduces, but surprisingly, considering interaction with the air conditioning and heating effects, maybe at higher temperatures, somehow the efficiency is increasing because mostly the air conditioning remains constant in spite of the increasing temperature. That might be the preference of the driver. Okay. Then that is research 1 that we discussed related to testing and experimenting on energy efficiency of electric vehicles. Now come to another research. This research is the first research that we saw here. This was based on GPS map data in Japan, I think. And the second research is creating one test environment structure. Okay. So second environment is creating one test environment structure, test chamber. There is a test chamber. So this is a typical test environment for measuring the efficiency of electric vehicles. So you have one electric vehicles on a platform. It is practically on a platform. We have wind speed simulation system or blower for coolant wind speed control, because when the vehicle travels at a very high speed, the wind also provides the required cooling. That's why ambient temperature is very important. We have one exhaust emission system. If there is, for HEV or whatever, for HEVs there will be an emission system. Fresh air system, humidity simulation system, air conditioning unit, heater to provide temperature control. And we have got humidity control, solar radiation intensity control because of the heat, to control the heat, because the vehicle will be subjected to heat and solar radiation when it is traveling on the road or flying on the road. So all these things must be simulated so as to provide an accurate estimate of the energy efficiency of the vehicles. So this paper is in Applied Thermal Engineering. It's a recent paper in 2024. So these are the parameters and the results. So this vehicle is a bit heavier compared to the first vehicle that we have seen, the smaller one. So it's around 1.7 tons, 290 Newton meter torque. Maximum power, that the first vehicle that we saw was only 30 kilowatt, but in this case it is 132 kilowatt, and here the maximum speed is 156, whereas it was 80 in the first case. And total energy of the battery power in kilowatt hour 54. So the popular models that we have in India has about 40 kilowatt hour battery packs, whereas this test vehicle has 55 kilowatt hour battery pack. And maximum range in this case is 410 for this battery pack. Okay, power consumptions per 100 kilometer is in this case 14.7 per 100 kilometer, 14.7 units. Again, putting this in context, whatever we have calculated 13 to 16 kilowatt hour per 100 kilometer for the vehicles flying on Indian roads. Now as the result, air conditioner power consumption. So air conditioner is run on time. So various comfort mode, what are the air conditioner power consumption is showing. Okay, and final power consumption it has found out to be 14.7, and further details you can find out from this paper. Okay. Now this is the third research that we will discuss regarding the energy efficiency of the electric vehicles. So this research has a specialty that it is on practical road, so on a practical traffic conditions. They have defined a route and they have driven the vehicles in that route and they have found out the results. So very elaborate data acquisition system is provided to this real-time vehicle. Okay, and data logger systems are provided which are connected by various sensors. So this is the typical architecture or structure of the vehicle that was used. It's a practical commercial vehicle that was used in this case. So in this particular case we have got one motor which drives the wheels. There is an inverter. Then we have got the battery pack. The battery pack is not exactly like this. It is a long one. It's a bigger one, and we have onboard charger which can be used to charge the battery. We have auxiliary power supplies. Another battery provided here. Low voltage DC, electrical system, auxiliary system, sensors, power module. These are provided. The 12-volt battery that we use. Okay, so and this paper is on an ECM. I'll recommend you to go through this paper. It's a nice one, providing details of the testing. Now these are the results that they have obtained. Again, while discussing the results, we will put our values here. So what we did, we obtained that about 15, we will assume 15 kilowatt hour per kilometer, and that comes out to be per 100 kilometer, that comes out to be 0.15 kilowatt hour per kilometer. And if we reverse that, so it will be 1 by 0.15 kilometer per kilowatt hour. So that's around, we'll check that, 6.6 kilometer per unit. Okay. So here also, as you see here, the energy efficiency in kilometer per kilowatt hour comes around various values starting from 4.5 up to it goes to around 8. Okay, and with when the ambient temperature rises, somehow the efficiency in this case has increased for there, and this seems to be the optimal temperature of operation. If it is too cold, the efficiency is very low. That has been found in this research. Then under different environments, so we have got urban, rural and highway. So in this case, the average speed increases, of course, when we go towards motorway, and in the urban the average speed is less, from 30 kmph to 90 kmph. Now energy efficiency reduces as we move towards motorway because the speed generally increases. Okay, so this completes our discussion on various real world driving scenarios and with which test scenarios. So we have seen two things: one small vehicle first, then we saw one test environment, and where the researchers have found out the impact of auxiliaries on electric vehicle efficiency, real efficiency. And finally we saw a practical test which has estimated the ambient temperature to be around 28 to 30 degrees centigrade to be the optimal one for providing the best efficiency for the electric vehicles. Okay, so with this we complete first two parts of our discussion.